Welcome to the lecture on weldability of cast iron. So, apart from steels, if you talk about the ferrous components, then cast iron is one of the very important material among the ferrous family, and we must be conversant with the weldability aspect of the cast iron. So, first of all we will have some knowledge about these cast iron family. So, as we know that the cast iron is a family of ferrous alloys that normally contain more than 2% carbon and 1 to 3% silicon, and also it has about it has very small amount, it has a small amount of sulfur and phosphorus. So, basically when you go from 2% carbon onwards, it is the family of cast iron, and also silicon is also playing very important role in the case of cast iron. So, if you talk about the variety of cast iron, so basically you have 4 type of cast iron. You have the gray cast iron, which then uses weldable, and it has we will talk about its traits later. Then you have white cast iron, which is considered normally having a very poor weldability. Then you have the malleable cast iron, and then you have this is a nodular cast iron, basically this is not. So, you have these 4 types of the cast iron which are available for as the type of the cast iron. So, malleable and nodular cast iron, they are weldable, but they require the post weld heat treatment. Now, if you talk about the gray cast iron, so gray cast iron, as you know that in the gray cast iron you have the graphite flakes. Graphite is in the form of flake. So, it will be showing the gray fracture surface, that is why it is known as the gray cast iron. So, in the case of if you talk about the gray cast iron, so the typical the percentage carbon is about 2.5 to 3.8%. Silicon will be 1 to 1.1 to 2.8%. Then you have manganese as 0.4 to 1%. Phosphorus is 0.15%. Sulfur is 0.1%, and iron is balance. So, that is why what you see is that you have the carbon and silicon are quite in considerable amount. So, because anyway carbon plus silicon by 3 is also defined as the carbon equivalent, even phosphorus also is taken into account in that way. So, basically you have the gray cast iron, which has this composition as carbon is about 2.5 to 3.8%. You have silicon as 1.1 to 2.8%, manganese 0.4 to 1, phosphorus 0.15, sulfur as 0.1, and then rest is iron. So, basically you have the role of each elements are there. Carbon and silicon, primarily you will have the graphitization, which is promoted by the presence of these, and then phosphorus is for the fluidity and all that. So, accordingly we define these materials. They are they have the carbon in the flaky graphite. So, and so you will have the free carbon in the graphite form, that is in flaky form, and in the case of other this is, so carbon is basically in the graphite form, that is in flaky form. Then they are easy to machine, they have other good damping properties and all that. Now, coming to its welding characteristics. So, it is probably among the most difficult among the metals to which can be welded economically, and that is because what is happening especially in the cast iron, especially in the gray cast iron. You require the formation of graphite, that is to be done at a very slow cooling rate, and that is again a challenge in the case of gray cast iron. So, you have also very much use of the welding of these parts, because you have a high number of parts and whose service is required. So, many a times you require to have, especially you require their application in the area of foundry, where you do have to repair, you have to the casting damage, and you have to the join together many cast sections. So, this way their use will be there. So, that way it has to be they are very important element among the variety of cast iron. If you talk about the malleable cast iron, so now in the malleable cast iron, your carbon is again in the free form, so it will be in a temper form. So, here you will have the quasi spheroidal type of carbon, that is temper carbon, and so the purpose the way it is made from white cast iron. So, since white cast iron cannot be used, so we use these malleable cast iron by giving the proper heat treatment to this material. And when you are doing the welding of the malleable iron, then it will be destroying that heat treatment. The heat treatment which is given to the white cast iron for making the malleable cast iron. So, when we are doing these welding of such steels, so basically that will be negating the effect of what heat treatment which we have given to these kind of materials. So, in these type of materials, you have lesser value of the silicon, because in this case the carbon we are getting from the white cast iron. So, in white cast iron itself you have less silicon, because silicon is the graphitizer. So, silicon will be in the range of 0.6 to 1.3%. You have carbon also on the lower side, maybe about 2.3%. Then you have manganese also less. So, 0.2 to 0.6, phosphorus is 0.15 and sulfur is 0.1 as usual. So, that way you have these malleable iron castings. Then the another type of cast iron which is important is the nodular cast iron, and nodular cast iron, as you see that it is in the case of the gray cast iron, you have the flaky graphite, whereas in this case you have the graphite which is there in the form of spheroids. So, you will have the nodular appearance of the graphite. So, that way it is known as the nodular graphite. So, most of the welding which is done is normally on the gray cast iron, and very less is done on the malleable and the nodular iron. Now, we will talk about the welding characteristics of the gray cast iron. So, if you see the in the weld pool, the cooling rate determines carbon going into the combined state or remaining in free form. So, certainly as we know that when you are increasing the cooling rate, then the most likely you are going to have the carbon going into the combined form. So, it will make Fe3C, and the whole purpose of making the gray cast iron is lost, and that is what is happening normally in the case of welding. In the case of welding, then in normal case the heating cooling rate is higher. So, it is very difficult to have the formation of graphite under the higher cooling rate conditions. So, you will have to reduce the cooling rate, and that normally is done by reducing so that by preheating the part to a temperature maybe about 600 to 700 degrees C, and then also you have to have the cooling slowly. So, that is the process which is followed while doing the welding of the gray cast iron. So, and also we do the post weld heat treatment of the job that will minimize the excessive cooling stresses and prevent the formation of the white cast iron. So, that is what is normally desired, because in this case if your heat treatment if you are not giving the proper heat treatment, then there is likelihood of the formation of combined carbon will be in the combined form, that is your Fe3C. So, that is what we normally do when we are talking about the welding of the cast iron. So, other techniques for the welding of the gray cast iron, so that is what we normally do, is that we use suitable non-ferrous electrodes of lower melting point than the gray cast iron. So, that is one way which we do for minimizing the excessive cooling rate. So, by this process we can do that. We do the use of skip welding technique to minimize heating of gray iron components. So, as we have understood that we go the skip welding. So, you skip welding as well as we go for the back step. So, what is done is that normally when we talk about the skip welding, so what we see is that if suppose you have a plate which is to be and if you are making the weld bead, so you will have different sections. So, suppose you have these are the 7 sections. So, what we do normally is that you go for the skipping. So, one part of the seam, and then the another part will be welded which will be away from that particular part. So, suppose you are doing the welding. So, you will be welding this part initially, and then you are leaving so you are not doing here, but rather you will be doing this. So, this is your skip welding part. So, this is suppose 1, then this will be 2, then you go to the third part. So, that way you will be doing this as the third part. So, then you can go for the fourth part like that. So, you are not doing continuously. So, that way. So, fourth will be there, then you start the 5, and then you go for the 6, and then you go for the 7. So, that way we use these skip welding techniques, and we also do the preheating, maybe 600 to 700 degrees C, that is preheating is done in these cases. And we can also have the good quality insulating. So, they are maybe covered with this good quality insulation, so that you have the good quality welded joints in these cases. Then in arc welding, you direct arc upon the already deposited weld metal, that is normally what is we try to have. So, we used to have these direction of the arc directly upon the already deposited weld metal. So, that is a type of post weld heat treatment in one sense. Then the filler metal which you are employing, so that also plays a very important role, and they should have the same coefficient of thermal expansion as that of the gray cast iron. So, whatever filler metal you are choosing, they must have the same type of thermal expansion as that of the gray cast iron. So, in that case the the undesirable effect will be minimum. Coming to the welding processes for the gray cast iron. So, the processes which are employed for the welding of gray cast iron are the shielded metal arc welding, gas metal arc welding, flux core arc welding, oxy fuel gas welding, braze welding, and thermite welding. So, all these processes are used and can be used for the welding of such cast iron. Then you have the preheating. So, preheating we are doing to decrease the cooling rate. So, it will be depending upon the factors like type of cast iron being welded, mass of casting, then welding process employed and type of filler used. So, these points are to be taken into account. Then you have the all cast iron to be preheated during oxy-fuel gas welding to reduce the heat input requirement. So, in those cases what you do is first of all you do the preheating so that your heat input requirement will be be smaller. So, that is what we follow in the case of the cast iron welding. Then we have already seen that local preheating has to be gradual, so that your cracking is avoided, especially in the complex shape of castings. Cast iron are arc welded with nickel alloy, mild steel and copper alloy covered electrodes. Root openings should be wide enough to permit good fusion into the root faces and also into the backing plate if used. And for the butt welds with V edge preparation, 60 to 80 degree groove angle, and for thick section U groove with 20 to 25 degree groove angle and 5 to 6.6 mm of root radius. So, these are basically the dimensions which should be followed normally for the welding conditions when you do the welding of the cast iron components. Then next when we are repairing the crack at the castings, a hole about 3.5 mm or larger in diameter should be drilled at the end of each crack to prevent its further propagation. So, that is another way to avoid the propagation of these crack, because in the case of the cast iron there is chance of the crack propagation, and because they are the brittle materials. So, that way it becomes even more severe. So, in those cases there is a practice that you must have the diameter of about 3.5 mm or larger, which should be drilled at the end of the crack, and then you can prevent its further propagation. Electrode has to be manipulated so that the bead width is not greater than 3 times the nominal diameter of the electrode. So, this is also one of the design from design point of view, it is important to know that what should be the diameter of the electrode chosen depending upon the bead width. For filling larger cavities, the sides should be buttered with weld metal first and then cavity gradually filled towards the center of the required area. So, that is basically the buttering which is done. So, when you have the larger cavities, in those cases the side are first of all buttered with the weld metal, and then you are filling the cavity gradually towards the center for the of the repaired area. Coming to the type of welding, as we have discussed, that backstep welding sequence will be providing you the better results for the large size castings. And to reduce the strain caused by the deposition of long bead, deposition of weld metal should be in short lengths and allow each bead to cool down before laying the next. So, that is what the skip welding process tells, because as we have seen earlier that when you are dividing this whole length into different sections, then you should not you should aim to avoid the welding in continuation in all the sections. So, basically what you do is you that way you can reduce that strain which is because of the deposition of the long bead. So, you are doing the weld metal in shorter lengths and then you are allowing that bead to cool. So, basically that was skip welding, But here what we do is that we do this small welding, length welding, and then we are stopping for some time and then further, because that way you will have the reduction in the strain. Upset and pinning of the deposited weld metal lightly before it cools and contracts is another alternative. So, as we have seen that we follow certain methods like upset or pinning also, because that will that pinning process will be giving the compressive stress, and that basically will try to blunt the cracks, which are micro cracks which are likely to come up after the welding. So, that is another alternative which is being followed in this situation. Combination of short welds and pin is basically the best practice. So, that is what we have seen. We should go for short weld and then do also pinning. Buttering and studding, they are method of getting sound and strong welds. So, what we have seen that we have studied that buttering process, where we are doing the buttering first buttering layer, and then we go for the final weld metal towards the center, and also we do the studding. So, that process is, so that is what we do normally. We are doing the studding to give quite a good strength in those cases. So, these methods. So, here it is showing the short bead length which is being provided, and this is studding way. This is a good way welding of welding or welding practice. Then we also go for the post weld heat treatment, and this is thermal stress relieving heat treatment is desirable for these especially for the fully restrained welds, and then wherever these components are supposed to be used, where there is close machining tolerance, in those cases you have to have the stress relieving treatment as a necessity. This is done normally immediately after the welding, and if the casting is welded with high preheat and interpass temperature, it should be slowly cooled by covering it with an insulating blanket or hot stand, as we have discussed hot sand. So, if you are insulating that, in that case the thermal gradient developed will be smaller, and in that case the chances of defect will be smaller. Now, if you talk about the welding aspect of the malleable iron. So, if you talk about the malleable cast iron, so in this case what is happening, that you are doing the heat treatment, annealing heat treatment, and then you are getting the temper carbon structure by the decomposition of the combined form, that is Fe3C. So, if the you are welding, and if the temperature is exceeding 760 degrees centigrade, and that is likely to be. So, in that case the structure, metallurgical structure of the heat affected zone part, where the heat is where it is going back. So, so because of the further the large cooling rate, that structure will be again becoming the white cast iron. So, you will have this is not desired in fact, because you have given a large annealing treatment, and you have made these malleable cast iron from white cast iron. So, basically you should not heat these malleable iron above that temperature, and otherwise you have to go for the malleabilizing treatment. So, that is not very much justified economically, because that takes a large amount of time. And so, but if that is the case, in that case you have to go for the treatment, you have to go for the heating around 850 degrees centigrade, hold there for an hour, and then for an hour for each 25 mm thickness, and then you are cooling in the furnace till again the 727 degrees centigrade, that is your lower critical temperature, and there you are further allowing it to be hold for large time, maybe for 5 to 6 hours, and then further you are cooling. So, that is what the annealing cycle is there for making the malleable cast iron. So, that you have to follow. most of these malleable cast iron, they are repair welded. So, they are normally you have to do the repair welded by the bronze welding. So, this is normally used, and you use the cast iron rods for the worn parts. So, if you go for the oxyacetylene or the arc welding, then they pose difficulties, because the temperature will go above 760, and then you will have to go for the malleabilizing treatment. So, that is normally for the malleable cast iron. And if you talk about the nodular cast iron, so nodular cast iron also is facing the same kind of difficulty as being faced by the malleable cast iron, because in the case of malleable in the case of nodular cast iron, what is the nodularization is being done by the elements like magnesium, and when you are basically heating, in that case if there is loss of magnesium, then this nodularization is gone. And when you are basically doing the welding, so depending upon the cooling rate, you will have the formation of the white iron mostly, and maybe gray iron if you are maintaining the cooling rate by preheating or so. But then the nodularization is basically gone because of the loss of Mg. So, what we do is normally the nodular cast, in the case of nodular cast iron, normally they can be brazed. So, we do the brazing of these components. We normally avoid the gas welding of these components, because again the same thing which is happening in the case of the malleable iron, similar problems may be encountered in the case of even the nodular cast iron. Apart from that, you have also alloy cast iron, which are similarly similar to the gray cast iron. They are also welded. The parent metal composition has to be there. So, if the filler composition is near to the parent metal composition, mostly it is preferred one. So, this is mainly about we discussed about the weldability aspects of the cast iron family. Thank you very much.